Let's start with the first problem. We're given y is equal to 3 over x minus 4. For this one, we want to list out the horizontal and vertical asymptotes, as well as any intercepts. For the horizontal asymptote, the degree of the bottom is bigger, so it's going to be 0. Vertical asymptote, we set the denominator equal to 0. For the y-intercept, we set x equal to 0. And there's no x-intercept because the top is just 3. So for the x-intercept, you could just set the top equal to 0. Okay. All right, so now we can graph this. We have horizontal asymptote, y equals 0. Vertical asymptote, x equals 4. And then we have a y-intercept, negative 3/4. And whenever we're graphing, we always want to make sure that the horizontal asymptote does not get crossed. And here, because there's no x-intercept, we can never cross the horizontal asymptote. Because crossing the horizontal asymptote would give us an x-intercept, which we don't have. So that doesn't make any sense in this case. Now, for the shape of the graph, this looks very similar to 1 over x. It's shifted over 4 units and then scaled by a factor of 3. So we know 1 over x looks something like this. So that's the same thing that's going to happen over here. And we're going to make sure we hit the y-intercept at negative 3/4. And we should be careful because it'll never cross the x-axis. Okay, for the next one, we have y is equal to x plus 1 over x squared plus 2x minus 3. It's always good to have this factored out. So that would be x plus 3, x minus 1. So we can get, let's see, horizontal asymptote will still be 0 because the degree of the bottom is greater. Vertical asymptote, we set the bottom equal to 0. And for the x-intercept, we could just set the top equal to 0. That's like a nice little shortcut. And we get x equals negative 1. Y-intercept, we set x equal to 0. We get negative 1/3. So now we can graph it. Horizontal asymptote, y equals 0. Vertical asymptote, x equals negative 3. X equals 1. X-intercept at negative 1. Y-intercept, negative 1/3. Okay. So this one is a bit different because we said the horizontal asymptote is 0, but you see how at negative 1 it is 0. So the question is, are we going to pass through that or not? Okay. And so this point it's a little difficult because there are basically 3 different regions we have to consider. So a good thing to do is draw a number line. You want to draw your your vertical asymptotes and your zeros. And you want to pick values in between. So if I'm going to pick a value to the left of negative 3, you can think of it as like negative 5. Plug it back into your original equation. So the original equation was this. So you do end up getting a negative number. If we pick a number between negative 3 and negative 1, we get a positive number. Pick a number between negative 1 and 1, say 0. That's negative because we said it's negative 1/3. And we pick a number to the right of 1, we get a positive number. Okay. So we have to be smart about this. To the right of 1, it's positive, but you want to be approaching the asymptotes. So we're going to approach the vertical asymptote, and then we're going to approach the horizontal asymptote like that. Now between negative 1 and 1, it's going to be negative. So we're going to connect here like this. And between negative 3 and negative 1, it's positive. So it'll look something like that. And then to the left of -3, it's negative. So it's obviously going to approach negative infinity, and then it's going to approach 0. So that is our graph. Okay. Last one, we'll be working with an oblique asymptote. So whenever the degree of the top is 1 greater than the bottom, we have a situation where it's an oblique asymptote. And the first thing to do is do long division or synthetic division. So you can either choose to do this, or you can do synthetic division. I'm going to pick synthetic division because that's easier. So I have a remainder of -4. So I'm going to put that over x plus 1. So these two, so this will be found and the original are equivalent. Now the reason we get an oblique asymptote is because as x approaches infinity, -4 over x plus 1 is going to go to 0. Because -4 over a huge number is basically 0. So as x approaches 0, my graph is going to approach x minus 2. So that's going to be my asymptote, and I'm going to put it as dotted, because that's how we represent asymptotes. There's a vertical asymptote when x is equal to -1. Okay, now we can set the top equal to 0 to get our x-intercept. So if we factor out the top, we get x minus 3, x plus 2. So we get -2 and 3 as our x-intercepts. If I plug in x equals 0 for the y-intercept, I get -6. So now we should be good for part of the graph. I could just connect the -6 and 3, and you want to approach negative infinity, obviously, because you want to approach an asymptote, and we're also going to approach the oblique asymptote, and then we're just going to connect these. On the left, I have the x-intercept at -2, and I don't know what's going to happen. Well, a couple things can happen. I can approach the... Well, I know I'm going to end up approaching the oblique asymptote, so it only makes sense that it's going to be something like this, and then get closer and closer to the oblique asymptote. But if you're not sure, you can always plug in a value. Let's say x equals -3/2, and you would get some positive number. Okay, and then you can also pick a number to the left of -2, and you would see it would be negative. So basically, what you have is something like this. Where right in the middle is your oblique asymptote. And you want to approach the oblique asymptote in the long run. So something like this. So that's how you graph that.